Alright, hello everybody, my name is Danny Cohen. This is my implementation of the goal points for CS61B Project 0 nbody. Now you can see here I'm on my bodyextreme.java and bodyextreme.java files. You can also see this is not code, so don't think that it is. Before I show my nbody extreme in action, I'll briefly explain what I did for the goal points for this project. So I went about implementing a manually movable spacecraft that is also subject to gravity. So I started off by doing a lot of Googling, trying to figure out how Java implements key press tracking, because I think that was the most difficult part. And after a lot of research, I found that in Java, the best you can do is track a key event. So the computer knows when a key has been pressed, but you have to make sure that Java is watching for it. And the easiest way to do this is to implement what's called a JFrame or a JPanel. So it looks pretty janky. It's this big panel that's right in the middle of the screen. But when you click on it, then Java knows to track key presses in that window. So if you didn't have that window to click on, then there wouldn't be any way for the code to recognize the key presses, because although the computer knows that the keys are being pressed, Java doesn't know to look for those key events. So that was the main thing that I had to change in my code, was obviously tracking those key presses. And then in that same vein, in my overarching nbody extreme class, I implemented 4 subclasses. One was called up action, one called down action, one called left action, and one called right action. And each of those had a method inside that indicated what to do when the left, right, up, and down keys were pressed, respectively. And what they did was they called a move method on the body class that, unlike the update method, doesn't calculate gravitational forces or anything. It simply subtracts a certain number from the x position if you click left, adds a certain number to the x position if you click right, adds to the y position if you click up, and subtracts from the y position if you click down. And it makes for a very simple implementation because it doesn't disrupt the calculations that determine the gravitational forces. It just shifts the location of the spacecraft when you click the arrow key. So to implement this properly, I had to also create a secondary constructor within the body extreme class that also included type. So by implementing a secondary constructor, I was able to make the default value for type planet, so I didn't have to go back and change all the constructors for the planets throughout nbodyextreme.java. But I was also able to declare my spacecraft as a body extreme, so I didn't have to make a new class, but I did declare its type as craft, and that made sure that I could exclude it from the gravitational calculations because I didn't want the mass of the spacecraft affecting the way the planets moved, only the other way around, because that seemed to make much more sense, because in the real world, pretty much no spacecraft is large enough to affect the gravitational field of a planet. Finally, I had to calibrate everything to work properly with planets.txt because I ran into an issue whereby if the spacecraft had a small enough mass, then it would almost immediately get sucked into the sun, or it would fly off the screen because it effectively couldn't stand up to the planets. So I had to set the mass of the spacecraft between a fifth and a tenth the size or the mass of the largest planet in the solar system, and that allowed it to still be visibly affected by gravity, but not so rapidly affected by gravity that you couldn't test it out and move it around with the arrow keys. So some issues with my implementation are that it doesn't automatically calibrate to every universe. This wouldn't be super hard to implement because you would probably just base it off of the average planet mass or the largest planet mass, but I couldn't figure out a perfect formula, so for this demonstration I've left it as is. Another issue is that if you fly too close to the sun, it'll suck you right in and then shoot you straight off the side of the animation because it doesn't know how to do collisions properly, so the program gets a little confused. And then one other big issue is that it's choppy, because in order to ensure that all the key presses were properly tracked, I had to implement a 10, or I guess not 10 millisecond, maybe a 1 millisecond pause in between registering a key press and then moving the spacecraft. So it's a little bit choppier when the spacecraft is moving than without, but it's almost not noticeable. So without further ado, I will run my program. And you can see how I'm clicking now, nothing's happening, but then once I click on this box, this JFrame, now I'm able to move the spacecraft depending on what buttons I'm pressing. So here you can see it's subject to the forces of gravity, it's moving in towards the sun, it's looping around, I'm not pressing anything, and now it's roughly stopped and almost no velocity. And now if I'm to use the arrow keys, I can sort of move it around the little map here, I can move it wherever I want. But then the issue, like I was talking about, is that if you fly too close to the sun, it will get confused and shoot itself right off. So in this case, you have to close it, and then you have to restart it, and then you're right back where you started. You have the spacecraft, click here to enable it, and then you can continue flying it around. So you'll just have to take my word for it that I am actually indeed pressing keys here to move it around. This is not just random movements, and you can also see that when I stop touching it, it is simply subject to the forces of gravity. So thank you, and that's my implementation of gold points for CS61B Project 0.